Hello YouTube. So I'm getting ready to install a BLTouch sensor. I've got most of the stuff I need in here. I'll also need some cables, but I'll go find that when we've just had a quick look at what the main components are. The one I've got is simply packaged in a piece of foam like this. We have a small bag with some crimp connectors and some screws. I think there's a couple of springs in there, otherwise they're here. We have the springs right here, and then some more connectors here. And then let's get the actual sensor out. This is a BLTouch sensor. Let's see if we can get some focus on that. It's probably struggling a bit here, but yeah, I can hear the focus going bananas. I don't know if you can read that, but it actually says BLTouch. It's just this little thing that actually physically senses the bed, as opposed to an inductive sensor that would sense a magnetic field when it gets close to the bed. This actually has a little physical plunger here that can move up and down. So it'll actually physically sense the bed. So when it touches, it'll pull that up, and you know, okay, we've hit the bed. And the way to the way to install it depends on your printer. In my case, we need to print some sort of mount. I have this one here, and I'll show you where that goes in a little while, because there are several different mounting options for this. You can put them in the front here, right next to the part cooling fan. You can put them in the back and various other stuff. In this case, this goes in the back. So let me just turn the printer around. So here we have a back view of the printer. Let's just move the camera up a bit. So this piece here, the 3D printed part, will actually take the place of this mounting bracket there is in here underneath the block where all the electrical connections is for the hot end. So that will actually go in, I'm not should be this area around. Then the BLTouch sensor will mount in these holes on the bottom here, like so. So it'll sit here on the back. Now what we need to do is connect a cable. So I need to find some cable, because obviously the cables on this is not long enough. So you can see they're like 10-15 centimeters. And we need a cable to follow this other ribbon cable all the way up here, over here, down here, and then down in the base there's a slot where we can get into the main board. And on the main board, we'll see that later, but on the main board there is some an unpopulated pin header we need to solder onto. Now hopefully I'll have some pin connectors that will fit that, the pitch of that header, so we can disconnect it if we need to, but otherwise we'll just have to solder it directly in. And to actually get the sensor here to work, we need to run a custom firmware. We need to run ADV i3++, which I have shown in a previous video how to flash onto one of these printers. It'll work on Wanhao, Maker Select, Cocoon Create, PowerSpec, all the clones of the Wanhao i3+. So to get on from here, I need to find some cables, some pin headers, and then we need to disassemble this whole thing and get the soldering iron out. So be right back. Okay, so we're inside. If you want to see exactly how to get inside, watch my previous video where I repair the bed thermistor. But what we need to do in here, there's these pin headers here that's unpopulated, one called C-probe and one called EXT. And we need to use 5 of those pins there. I'll throw a schematic up on screen from the manual, but luckily I found some pin headers that fit. So we'll install these. I think they go something like that. I'll just have to double check that. Then I also found some cable. And you'll see I've installed 5 pins, that's what we need. And I found some cable, that ribbon cable that happens to have 5 strands. So that's perfect. And I've got like 5 meters of it, of the stuff or something, so that should be plenty. So yeah, I'll disconnect, or well, I don't know if I'd actually disconnect because it's hot snotted in, so I might just try to see if I can do this in place. So I've soldered in the pins. I did that off camera because by experience I cannot solder with the camera in front of me or in between me and my work. I just want to clean off the flux here. So just a cotton swab and a little bit of alcohol. So, and if we look around at the other side here, okay, they aren't really straight, as you can see, but it would be easier if you had actual pin headers for these specific, yeah, 10 pin header and so on for this. But right now it's upside down. But over here we've populated pin 1 and pin 9 and 10. And over here we populate what is marked in the manual as 2 and 3. They aren't actually marked on the board, but the 2 farthest away from the ribbon connector over here. So now we just need to prepare a wire. So I need to get this crimped. There's some pin headers and stuff with the BLTouch. Let's see if I can find it. There's some stuff in here. Let's just try and get that out. So we have these. This goes on the cable and this goes in here, and then this can go on here. Although, as far as I can see, there's also a small jumper. I don't think this is used in this model. And I also only see 3 of these, but there's more in the styrofoam as far as I remember. Yeah, there's these both 2 and 3 thingies. So I'll get that done. I won't show that on camera either because honestly I'm not very experienced with this kind of work, so whatever I do you probably shouldn't do. I'm sure somebody else has made a lot better tutorial about that kind of stuff. Okay, so it's the next day actually, and I've really been struggling with crimping these tiny connectors. The thing is, I don't actually have a proper crimp tool for these. I just have this, and It's quite big compared to what we're trying to crimp here. And the thing is, if you just squeeze this a little bit too hard in the wrong place, then when you get the male end that needs to fit with it, then that can't really get in there. So this one should work. That works okay. It's not really getting in there. This one I think is bad also. So I was thinking, okay, what can we do to make this a bit easier on ourselves? So I found these. They're already pre-crimped. So I figure I just cut these in half. Then I've got the male and female ends that I need. And then it's just a matter of doing a simple wire splice onto this cable here. So I'm gonna try that instead, because yeah, this is just not working out and I'm running out of connectors, and it's not gonna work. If you're gonna do this, you need the proper tool probably, or at least you need something smaller than this. This is way too big for these small connectors. So I'm gonna try this method instead. So yeah, that's the plan. Okay, so that's one done, except I screwed it up a little bit. I heated the heat shrink too much and I melted the insulation, so I'm gonna put a bigger heat shrink piece over top of that, but otherwise that's the process. I'm just gonna do this for all the wires and then we'll continue. Okay, so I've got one end of the cable done. Tried to color code them according to what's actually on the BLTouch, so I know that, yeah, because this cable doesn't match, so I've color coded the ends at least. So now I just need to get this installed here. Then we need to get the tower back on to measure out how long the cable needs to be exactly. Now the manual actually specified it should be 1.35 meters. I just want to check that before I actually cut anything. But this end of the cable is done, so we can install that and we can actually close up the button. Maybe I'll keep the lid on if I need to switch a cable, but let's just get this back in there. And then we see, yeah, that's maybe why this needs to be so long, this cable, because it doesn't just have to go up the tower over to the middle and down to the extruder, up the tower, yeah. It also has to go these like 20 centimeters here, so all in all it ends up being quite a lot. But we're just gonna thread this in here, and then could just give it a zip tie to connect it to all this other stuff in here. But I just want to get it down behind this, then I kind of think it will be pretty much in place. Actually, rather than zip tying, if I just run it under here, if I can do that, then I don't really need to zip tie anything, then it will be pretty much kept in place on its own, just by snaking it around here, like so, and then under these, and then that's not really going anywhere. And then I kind of want to see, can we Yeah, that's too tight. Anyway, now I just need to wire these up to the schematic. I should have shown that, a screenshot of that early in the video, but I don't remember it, so I'll just have to go and look it up. Okay, so I think that's right. Now remember, compared to the schematics, this is upside down, so we have got black, white, red, brown in the back, and orange there. And I'll just note down which color connects to which color on this ribbon cable. So once I've done that, and I can close this up. Actually, I'll just take a picture, I think, with my phone. And then I can close this up, and then we should basically just have to install, measure out the length of the wire, and then add these at the other end, and mount the BLTouch sensor. Then we need to flash the firmware. I don't think I'll show that because I showed that in a previous video. And then we should be ready to test it. And that's the fun part, right? So I'll get on with it. Okay, so I've got the printer back together. Now the bracket for the touch sensor will be located about here, and it does have a little bit of cable that'll go maybe, let's say, up to here. So we want the other end of this cable we've just installed to be able to reach that. It should follow, I think it should follow this cable we have here, the ribbon cable going down to the extruder. So I'm just gonna do a rough measurement and say I'll have to go like this, I'll have to go like that, do a turn, I'll have to go down, reach down to at least there. Let's give it 5 extra centimeters or so, because we can just pull the cable back into the machine down here. You can't quite see that, it's on the wrong side, but we can just push, we have excess cable, we can just push that into the machine. So I'm thinking, and it's that the extruder is down as low as it can go and out to one side. So that should be the furthest that this cable will have to reach. So let's just double check. Goes in here, goes over there, goes down there. So let's say let's cut it there. So just gonna cut it like so, and I'll even get a little bit extra length by where those. So now I just have to repeat the same process as I did the other end and splice all these wires. I'll look at my pictures so I can color code them correctly so they match, roughly matches what's on here. And then we'll need to install the actual sensor. So I'll get splicing. Okay, so I've done with all the wire splicing. You'll see that's plenty long, but we can pull it back a bit. Now to actually install the sensor, it needs to go in place of this. So first of all, we need to get this disassembled. Remove that, get that out of the way. And well, all the cables are slightly different, but just to remember what goes where, I'll snap a few pictures. So I have some chance of putting it back together correctly. So we've removed that. Now we need to get this off entirely. So there we have the whole assembly, and what will actually happen is we will replace this metal bracket with this plastic one. So we need to get the board out of there. Now we have the little daughter boards, and now this was on the bottom. This one will actually go on the top like so. Now I just gotta check if these screws actually fit. It does look like I might have to drill out the holes a little bit. So that's a very tight fit. Let's check the other holes as well. Yeah, I think I'll have to drill out all the holes. They're just a bit too tight of a fit, except the ones that go in the back there, so I'll just get that done. So I got the holes a little bit larger. Just one note, when you're drilling in plastic like this, in a 3D print, you can't just go straight to the hole size you want. You want basically the smallest drill that just barely fits or can't quite fit. Drill that and step up to the next size and the next size and the next size. Otherwise you're just going to crack the plastic. So be patient. Anyway, let's see if we can get this installed. Just want to see how this is supposed to fit. I'm actually a little bit worried that the nuts I need in here are gonna short out the pins on this. Because this goes like this, and then see if we can see that. In there's pins for this header, and the nuts to attach the sensor goes like right in here. That's going to be pretty close to those pins. We'll do a test fit, then we'll stick a bit of electrical tape on there if it looks too close. So let's see. So the sensor goes like this. I'm not actually sure if it's supposed to have the cable this way. I'll just double check the pictures. Well, the guy who made this design does have it mounted like this, so it'll go in towards that. Then you have this little circuit board down here. So what we want to do here is we need first a washer, then through the sensor, and then we have these springs, and then that will go through this board here, like so. And now let's see if I didn't actually drill this hole enough. No, that's fine. And then we need the tiny nuts on the other side, which I'll probably have to do off camera. I don't know if I can do this. Might be fine. So that goes on there. And then with this, you have a little bit of adjustment with the spring in there and stuff. So we'll do the other side. Washer. And now, of course, I shouldn't have mounted or put the nut on the other side because I can't get the spring in there now. I always say this is supposed to tighten all the way pretty much to fit this printer. I don't have a tool to do that right here. So we're just gonna hand tighten this as much as I can and then we'll fit it. Then we'll do a test fit at least. Because I just want to see how this looks. Yeah, they're definitely gonna touch. Oh, but he did mention something about those washers here for this board, and he put them on the other side actually. Yeah, now it can probably just about sit there, but it's still a very rare tight fit, and I haven't really tightened this. Those nuts are going to go way higher actually. So if he's tightening them up all the way, then there won't be room. Oh, so that's maybe not a great design. At the very least, I'll need some longer screws to do this. Yeah, I think that's what I'm gonna do. I'm gonna try and see if I can find some longer screws. Then we're gonna add some more spacing in here, either with some more nuts or something to lift that up. But then we have the issue of, does the cover then fit? That is luckily a bit adjustable, so it can go as high as that. That might give us enough clearance, barely. Okay, so I need to gather some more stuff to make this happen. Yeah. Okay, so I think I figured out a solution. First of all, I've gotten some shorter screws, found some shorter screws for the, let's see, come on. Here for mounting the actual sensor. And so they don't go as high when it's all the way tight. And then I found some longer screws for the actual board here. And then I have the spacer that was in there originally down at the bottom. Then I also have a nut in here to lift it even more. And then it goes all the way through and has a nut on the bottom as well, just to keep it secure. So now I hope this will fit. Now of course I just realized I'll need to take this apart again because I actually need to screw it into that. But anyways, that can be done. So let's see if we can get this loose. Hopefully there'll be enough spacing. So it will go like that. So I have these big ass screws though. Yeah, that's the problem. They don't actually clear the nuts I have there right now. Well, maybe just with a little bit of luck. You can see that they are interfering with the nut there, but just a little bit of wiggling, and I could just about get it through. At least I got one side. See if we can't get the other. See if we can get that in there. Also, I'll have to do it by hand, but if you can just get it going here, I'll be quite happy. So it's starting to look like something. Yeah, I just need to find something to tighten that by hand. Okay, it feels like that's on there fairly securely. I just need to see if I can actually get this back in. Good. Can I get the nuts on as well? I mean, we're almost done here. I just need to mount this, wire everything up, and then we're ready to reflash the firmware. So we're so close to the goal. So that seems to be in place. Now we can put this, there's the stepper motor. And then, as far as I remember, the next one was the... Well, that might be a problem. Because now this is mounted higher. This cable from the for the hot end doesn't quite reach. Well, just about get it there, but damn, that's tight now. And I need to get another cable in there. Just need to check my pictures. Part cooling fan. Oh, should be this one. Then the filament cooling fan. Should be the next one. Then we have this one, that's the Thermistor. That should be into the red one here. And then we have the CN stop, goes in there. And now I think it's going to be a problem to get this one, the last one, to actually reach. That's going to be a challenge. So I'm not sure about this design on this mount here. There's a few things about it that's not quite there, in my opinion. Seems like we may have managed to get that there, but that's damn tight. I hope we don't damage anything. And then we'll need this one. It goes in the back like so. And now the test is to see if the cover will actually fit. And I didn't drill those holes, so yep. Tight fit, but that's good. Means it's just, this means it's actually gripping. Since there won't be a knot on the other side of this one. Although the other side is not as willing. Okay. There we go. Then we just need to hook up the actual sensor here. So I think I'll route these up here, behind here, and they'll kind of stay there, I hope. And then we just match the colors, like we did in 3rd grade or whatever. And brown. And then we have whites and black on this one. go. Then we can trim this cable back. And that's supposed to go there. Or is it? No, that's not supposed to go there. So we can trim it back a bit more. I'm pretty sure. A lot more maybe even. Let's just see, it's supposed to be roughly that length, yeah. So here we have the final product, more or less. I haven't flashed the new firmware yet, but I just want to try a power on test. Let me see, it does its self-test. If it's supposed to shine red now, or it's supposed to blue, or whatever, I don't know. But we don't have the actual firmware. So I just want to try and see if the cables are long enough. So I'm gonna go into control, move. Let's try homing. And see what happens. It does look like it's above the nozzle, so it shouldn't crash into the bed. So that's fine. And then we'll see those cables there. If it unplugs itself. And you can't obviously not see the bed right now. But nope. It's just about, I don't know, 3 millimeters above the bed while it's retracted. See the cables there. Let's try homing X as well. See how far they reach. It seems about right. There's maybe a little bit of tension on them now, so I think I'm gonna give them. So you see that it's a little bit tight. Well, not tight, but I think I just want to give it 2 centimeters extra. So that's it, it's installed. Now I just need to flash the firmware. I'll just add some zip ties to make sure these 2 cables roughly stay together. It's not flapping in the breeze. And then I'll put it back in its spot and hook up Octoprint, and we'll try flashing the actual firmware and see what that gets us. So here we have the print up and running, and if we go into tuning, sensor, and leveling, we'll see it actually functioning. But, as we'll see in a little bit, there is a problem. The problem is the firmware thinks that the probe is sitting here, because that's where the official mount is. But I want a different cooler on where it wouldn't actually fit here. Yeah, cooler design. So I've mounted it in the back instead, but the firmware thinks it's here. So now it thinks it's probing the front of the bed, even though it's actually probing more like the middle. And it's doing 9 points. Maybe you can read that down here. I don't know if you can see that, but it says 2 out of 9 right now. When it gets to the 7th point, it goes off the bed in the back. So how do we fix this? Well, I was reading up a little bit on the GitHub for this firmware, and it seems it's actually already implemented a feature for changing this in an alpha version that's not been released yet. And I don't really want to run that until there's an official release. So what can we do? Well, we'll have to build it ourselves, because that offset compared to where the probe is compared to the nozzle, that's actually hard-coded into a configuration file that's only used when it's built. You can't actually change it when the printer is up and running in the firmware. You can't just send a G-code command to change it, unfortunately. So we will have to go to the computer and figure out if we can build this ourselves and make a new hex file and reflash the printer. So we'll go to the computer right now, and now you'll, well, wait 5 seconds, because then we'll see it going off the bed, and then we'll get a fail message. You see now it's trying to probe outside of the bed. It hit the CN stop, it didn't find anything, and now that it just did a little flag, and it says the version of LCD and the version of the mainboard is not corresponding. That's not true. That's a different, for some reason it suddenly gives me a different error message, but it gives me an error when it reaches that point. So we have to go and make a new build.
Okay, so we're at the computer. Now I tried building it with the Arduino IDE. Unfortunately, when I enable the BLTouch support, by uncommenting this line, I get an error. And then it says the preferred way to build is with Platform IO. Platform IO is an extension for Visual Studio Code, VS Code. Personally, I hate this product when you're used to using actual Visual Studio. This just feels like, yeah, just weird. Anyway, we need to add an extension. So you install Visual Studio Code, you go to extensions, and we have Platform IO IDE here. We'll install that. Okay, so after installing Platform IO, we get this extra tab out here. And once we're in here, we say open project. We go to the root of the file. You can download that from the GitHub. If you go to the ADVIPP Marlin GitHub and say download zip and extract that, then just go to the root and press open, and then we have this. And this was not obvious to me at all, but if we go to terminal and run build task, you can choose which version you want, the debug version or the standard version, and do you want the BLTouch or no. So I want the BLTouch, but we need to make a few changes first. The changes we need to make should be in the configuration H file. So let's find that. Configuration.h. And let's close this window so we can see what's going on. And we need to find something at offset. And that's used a lot. Here we have them. So we've got cprod offset from extruder. You can actually change that both through the menus on the printer or via G-code. But the problem is the X and Y probe offsets are not adjustable in any way unless you run the new alpha. And then you probably have to go to the dev branch. So we see here the BLTouch sensor that they have in mind. I have a picture of it here where it's mounted. Let's see, here it is. That's actually sitting in front and to the left of the nozzle, whereas ours is sitting back here, but they have a back mounted cooling fan. I want a front mounted fan. So basically we need to change this to make this sit to the rear about 65 millimeters. That shouldn't be minus then. And then about 15 millimeters to the right instead of the left. I'll just double check those numbers with my mount. Okay, so the actual numbers are about 11 millimeters and 55. So now we just go to run build task. We'll do the BLTouch. And we got errors. Why do we get errors now? Oh, so we actually have to do additional changes because the front probe bed position wouldn't work with this setup. So we need to find that as well. So where could that be? Can we? Yeah. So we have an issue. It wants to probe at the front of the bed at 10 millimeters, but the probe is actually sitting 55 millimeters back. So we should change that to 65. Then in regards to the right probe position, we could bump that up to, because it's sitting to the right of the nozzle, so we could bump that up to maybe 190. Back probe bed position, that would be left probe position, that's okay-ish. Back probe, let's try 200. I have no idea, to be honest. But it seems to be a built-in check, so we'll just see if that helps. It seems to like that a lot better. So what we can do now is flash this. We might have to go back and readjust some of these settings. They are all in the configuration.h file. So we should have a built firmware now. If we go into the ADVI3++ Marlin folder, then this platform IO stuff has created a new folder called .pioenvs. We go into that, then we have our build i3 plus BLTouch, and then we have a firmware hex file, which I suspect that's what we are going to need. The flashing process is as you've seen in the previous video, where I flashed this ADVI3++ firmware.
So we're back at the printer running the new stuff that I built. And yeah, it does seem like it's further forward. It could be even further forward. We want this as close to the front of the bed because the sensor is quite far back. So you want this as close as to the front of the bed as possible, because otherwise you might have issues with the front not being level as the rest of the bed. And that was roughly in the middle of the bed rather than a bit to one side as we saw before. I can definitely go closer to the edges, although we don't necessarily want that because we are rarely printing very close to the edge of the bed, so it's fine. We just wanted a mesh that's pretty much, you know, square for the bed. So we've got, this is about, see, 8 centimeters from the rear of the bed. Before it was maybe 2 centimeters from the rear of the bed, and then the last pass was way off the bed. We'll see if this passes within the actual best bed size. I hope so. Otherwise I'll have to go back and make new changes. I want to see the actual results in the end. I haven't actually leveled this bed or anything. Even if you have auto bed leveling, you should level your bed, roughly at least. I haven't done anything here other than make sure that the center of the bed was fairly level, but or at the right offset. Other than that, I haven't done anything. And it does look like we are going to be within the bed, so that's good. Although it said leveling failed, so that rear thing might be too low for us to actually do a level. So I'll just try and get back to you and then I'll show you the results or fix it. So there we have it. I had a few issues with it failing on the 7th point because the back left corner, that one, was way too low. It was triggering the CN stop before the sensor triggered. And the CN stop is still used in this as a reference point and as a safety feature. So if that's too low, if that triggers before the sensor, then you have an issue. There's possibly 2 solutions to this. Either we could lower the sensor a little bit, we can adjust the screws, I could get it like a millimeter lower. That would probably be a good idea. But what I did here was just raise the corner. So you see, I don't know if this is including the offset or not. Probably is. You can see the right side of the bed over here is quite high. The middle, so the right side and the front is fairly high, and then we have a dip in the back corner. But that's fine, because that means we have an uneven bed, so it varies almost more than a millimeter in height. So I think this is actually a good test. What I'm going to do now is try to slice up, let's say 5 benches, one in the middle of the bed and one in each corner. And then we can compare. That should come out the same, because we have auto bed leveling now. So we need to go to a computer now, and we need to do something with our G-code. In Cura you have a starting G-code, commands that's always run before a print starts, added to the start of every G-code file. Now that we have auto bed leveling, we need to change that. So let's go ahead and have a look at that.
So here we have 5 benches all loaded up, ready to go. First we need to go into the settings. It must be under printers. And don't mind that I just named it the i3. That's just because it has roughly the same dimensions. Machine settings. So here we have some start G-code and end G-code. So if we have a look at the manual for the IDVI 3++ firmware. And we go down to the BLTouch sensor section. Scroll almost always the way to the bottom. Then we have some starting G code. We see that they have G28, they home, and then they do a G29 before they start printing. And we basically need to insert a G29 after our homing action, otherwise this will not work. So what I'm thinking is we want G29. So I'm thinking we want it basically just after our G28. See, where did they put it? They raised the head first. So basically after this. So we basically just want to input a G29 here. And that should be good. Then we prime the extruder and so on. That's good. So I think that's basically it. I just put it right after they lift the head slightly here. So let's slice it up and see how it turns out.
So it's not benches. It ended up being just calibration cubes because Cura's having trouble slicing 5 of them at once. And it will probably take forever to print, so with all the details. So instead we're doing calibration cubes. And I'll just clean the nozzle here so don't drag too much stuff around. Now we should see it going through its leveling procedure. And I've moved in the parameters so it doesn't get all the way to the front because it can't since the sensor is in the back. So it won't go all the way to the rear either. It will stay about the same distance from the rear as it does from the front. And that's just thinking, well, that's a rectangle, and hopefully the firmware can extrapolate how the bed looks from there, because I don't know what it really does in regards to, well, if you're not measuring an even size of the bed. Anyway, I can already see the problem. The nozzle is oozing a lot while it's doing this level calibration, and leaving stuff all over the bed, which is not nice. So I'm thinking if we can get the starting G code to heat the bed, then do the leveling procedure, and then heat the nozzle, that would be ideal. So yeah, I don't know. That's maybe something you can play around with yourself. It's just an idea. Anyway, looks like it accepted the G code, and we'll have a look at the final result in, yeah, Cura said 1.5 hours, so we'll see. So we are having problems immediately. I don't know if you can see that on camera, but the nozzle is way too high off the bed. So there's an easy fix for that. We'll have to stop the print. Then we'll have to go into settings. And I think it's in the sensor settings. The C offset. Right now we want the nozzle lower than where it thinks the bed is. So we need to adjust this. Should be into the minus. So let's try lowering it 1 millimeter. There we go. So say -1 millimeter, because it's way high. And where you find that is in the settings menu, sensor, and there we have it. So I'm gonna clean this bed and try again. The print is done, and it looked like we have perfect bed adhesion all around, or maybe not perfect, but good bed adhesion, even though this corner over here, closest to the camera, is about 1 millimeter higher than the back corner over here. So it definitely seems to be doing the trick. That would never have worked if I didn't have a sensor for this. A few thoughts on the whole project here. First of all, you can't quite see it now. Maybe you can see. These connectors up here, these pin connectors. If you don't have the right tool for the job, don't try crimping them. Just get a set of cheap breadboard wires with the pins already attached and splice the wires onto that. That's way, way easier. If you don't have the right tools, at least. If we zoom in here, you see there's quite a bit of gap between where the sensor is now. It's probably hard to tell on camera, but we are talking about probably 3, 4, 5 millimeters. And I had that problem initially where this back corner was too low. It was triggering the CN stop before the sensor triggered. So what I could do is probably lower the sensor a little bit. It's on those spring-loaded connections, so I can. Now I've threaded shorter screws, so I can't lower it 5 millimeters, but I can lower it 1 or 2 millimeter. That would help a lot in that regards. We had the firmware issue where we had to compile our own firmware, and well, as far as I could tell from the GitHub, there was an issue there, open and closed, and the developer said that he has actually implemented a feature where you can adjust the probe YX offset in the firmware. So maybe when you see this video, this is not an issue anymore, but I had to compile my own. It took a little bit of doing, but it's possible. So yeah, I think that's about it. You can discuss if the mounting in the back is the best way to do it. Ideally, you want it as close to the nozzle as possible, but it does seem to work as it is. Let's just see if we can have a look at a couple of these cubes. So I'll take the ones from the two corners. That was this corner over here closest to the camera was really high, and the one in the back where the sensor is was really low. There was about a millimeter, maybe even more than a millimeter in between them, according to the sensor. Let's see if we can get some focus on this. So I don't know if you can see that. The finish is not quite perfect. It's not quite the same on both of them, but I mean, it definitely does compensate for something. It definitely has helped. That's not a millimeter in difference, because one of the cubes would have been welded to the bed and the other one would have not had any adhesion at all. This is like, it has compensated, but not quite. Maybe because the rectangle I set up, it can't, the sensor as it is now can't get all the way to the front of the bed, and I reduced it so it doesn't go all the way to the back. So maybe that's it. But I mean, it definitely does the trick. So all in all, I'm quite happy with it. I just need to go over here and do the same thing to my Wanhao. And on the Wanhao, you can actually see why I decided to stick the sensor in the back. I have this cooler mounted here, and that sticks out a bit to the sides, and it's round down here. So if you follow the actual official instructions, the sensor would sit right here, but it just can't, at least not with the mount that they had. I could maybe design my own that goes out a little bit further and then just clears this cooler. That's an option. Maybe we'll have a look at that in the future, but for now I'm quite happy, and I'm quite happy to proceed with doing this on my Wanhao as well, even though it took a long time with all the, especially fiddling around with the connectors and figuring out what to do with the firmware. But now I know, so it shouldn't take more than an hour or two really to get it up and running on the second printer, because now I know all the pitfalls, and as do you. So hopefully you won't have the same issues. So that's it for now. Like, subscribe, do all that stuff. And until next time, take care.